this is on page 161, just a random little thing. He says that the beach also reminds us of time. The world is much older than the human species. The beach, as in the accumulation of sand over erosion. So all the sand that we have on the beaches in the world are a present image of the passage of time. So I thought that was an interesting little item. And this next part is actually an image I wanted to show you on page 163. It's showing how the constellations have changed over time, such as the Big Dipper. Here's how the Big Dipper would have looked. I don't know if you can read that. 1 million years ago, I think, the very top. And you see how it's transitioned to the Big Dipper as we see it today. So I thought that was interesting also, something that we may not remember. The top one was 1 million years ago, and the middle one was 500,000 years ago. So, of course, no one was around 1 million years ago, but I thought that might be interesting to maybe we've forgotten about that those things changed. He mentions a quick point here about space and time, which I think is very fascinating. This is on page 165. Space and time are interwoven. We cannot look out into space without looking back into time. What this idea is, it's nothing different in terms of looking and observing the Earth and walking around the Earth. It's just made a lot more massive in effect, because when we look out into space, either on Earth or up in a space station, you are seeing old light. You are seeing the past, because that light took years, light years sometimes, I guess always light years, although our sun, apparently it's 8 minutes old. The light that we see from the sun is 8 minutes old. So to give you an example, if for some reason the sun were to explode, we would not know about it until 8 minutes from when the sun exploded, because while we're sitting here, we're still getting the sun's old light, and we're always getting the sun's old light. Not until 8 minutes had passed would we see the effects of the explosion. Then the sun would explode, and then whatever else would happen, we would see. So when we look out into space, we're always seeing the past. In a sense, that's true even on this Earth. It's just the effects are so tiny, because light does have a speed. So if light didn't have a speed, none of this would happen, by the way, which is another kind of thought experiment. But when we look out our balconies, for example, we are also seeing old light that's bouncing around. The building we look at, again, we're seeing the past, but it's like a millisecond. It's so tiny, the time difference. And we're looking at someone walking down the sidewalk or walking their dog. We are seeing them just a tiny bit in the past as compared to where they are actually in that instant. The time, I think it might be called time dilation, is so tiny in a distance of only 500 meters, let's say. But it's much greater. We're talking millions of kilometers, which I don't know what the distance of the sun is, but it's something like that. There, now it starts to matter. Now we're actually seeing the past, and that's very measurable. But that effect is still happening on Earth. It's just that because of the speed of light is so fast compared to the small distances that we actually see with our eyes, that effect is so tiny as to not matter as much. But it does matter in space. Now, if light had an infinite speed, this wouldn't be an issue, because whatever you observe is whatever is happening immediately at that point. You are always seeing the present. And if we looked out into space, we would still see all those stars, but we would be seeing them exactly as they are. So if there were to be a star that we can see on our solar, or that we can see in looking up out into space from Earth, if one of those stars were to explode, as opposed to us waiting a generation to see that star actually explode because of all the old light coming in, if light had infinite speed, then we would see it immediately explode. So that wouldn't be a factor anymore. But anyways, so I thought that's interesting fact to think about. It has little effect on us on Earth, but it matters a great deal in space because of the distance is just so much more astronomical.
than the Earth's distance. And that starts to matter. You may even kind of give the parallel of Newton's physics versus Einsteinian physics. Newton's physics works very well for the Earth, but it doesn't work as well, I guess, apparently, when you're dealing with the space. We're dealing with massive distances, massive objects, and black holes, apparently. They're out there somewhere, and things like that.